Welcome to Table for One, building a competitive paper-based AI. My name is Arthur Franz. This is a presentation that I provided years ago, just a little bit about me. I'm the designer, one of 4 designers of Breakaway Football, which has been out since 2017. Breakaway Football has over 40 unique teams that represent iconic single seasons from professional football, and the idea is to play them head-to-head from different eras. You could play a team from the 80s against a team from modern times and see how it works out. I'm also a writer and a podcast contributor. I have contributed to Meeple Mountain in the past and have been on countless podcasts. And lastly, I'm a learning and development manager, and so my discipline is learning and development, specifically in adult settings. And so what we're going to be talking about today is really solo modes and explore what works about solo modes and what you want to watch out for. Present 2 basic solo modes that I call a chaos engine and a reactive machine. And then I'm going to offer you a little bit of guidance on how to create your own paper-based solo mode. And then lastly, we'll talk about the evolution of Breakaway Football's AI, where it started, which was not great, and where it ended up, which is award-winning. What is a solo mode? It's an additional set of rules allowing a single player to play a multiplayer board game by themselves. And so effective solo modes offer quite a few things that we're going to take a look at. The first thing is suspended disbelief. You feel like you're playing against a real person, not a piece of paper, not a bot, and the decisions it's making are both plausible and appropriate for the game state. It also makes it easy for you to use from a cognitive load standpoint. The user interface is easy to interpret. The input and output that you have to process is quick and painless. Operating the bot does not distract you from your strategy. And lastly, it has to provide sufficient challenge. It doesn't need to be predictable or easily decoded, because then it's an activity of just sort of figuring out what the bot's likely to do, and then you do that. It may actually render some of your choices within the game state not super effective, but it's a good way to kind of game the bot. I like the idea of being able to turn the difficulty up and down, as well as your skill level increases, the bot's skill level should also increase. So let's talk about what we've learned from research and feedback. I like to explore what works in designs that I admire, and so if you're looking to build your own AI, go ahead and do that as well. Find things that reference the games that you admire, read blog posts about those, and learn what makes those games tick. I say be wary of the top 10 articles. Those are really just veiled marketing ploys to get you to buy certain games. But if you've got kind of a deep dive on a game that you really like that goes into the design, that's a great resource. Also, you want to think critically about what doesn't work in a solo game. And it's okay to be critical at this point because you're not trying to cascade that into your own game. Be fair and honest about where a game underperforms. And I find it helpful to keep a running list of don'ts just so that I know what to avoid in my game. Lastly, seek out feedback on your designs. You want to get people involved, playtesters as well as other designers, and make sure that you're testing the design frequently. Because it's solo mode, you control how often you want to do that, and basically just get it on the table as often as you can. Let's take a look at some solo modes that underperform, and this is no disrespect to these games. A lot of these games are super fun, and I play the solo modes of these games, but I do like to talk about that list of don'ts and really kind of piece together what it is I'm trying to avoid when I'm designing an AI for paper. The first one is disproportionate randomness. This is when a card draw alone plays too great a role in success or failure. And I've listed Arc Nova and Grand Austria Hotel as 2 opportunities there. Arc Nova is probably the one that makes the most sense to me. That's the one I've played the most. I like the game, but the deck of cards is so thick, I think it's like 270 plus cards, that if I have a particular strategy I'm trying to follow, maybe I'm trying to build out my reptiles, I am really at the whim of whatever comes up in the deck. And so it's hard to build a cohesive strategy. It's really more I'm reacting to whatever the card deck gives me and then trying to cobble together the best version of a zoo that I can from that. So that amount of randomness is disproportionate. I would rather a mechanism that lets me go dive into the deck and maybe mine it for certain things that I'm looking for. Another thing to watch out for is what's called a closed loop. So this is the opposite problem. It's not enough randomness. This is when a game feels solvable after a few plays. These are a couple of examples of Feast for Odin and Lords of Hellas. I have not played these games routinely, but what I do is I lurk in one of these Facebook groups that's specific to solo board gaming. And what I do there is look for these kinds of trends with respect to different games. Hey, has anybody else figured out a Feast for Odin if you do this, this, and this? I remember that Puerto Rico had that problem in an earlier iteration. I think the first version of Puerto Rico, you kind of had the book on it that you would sort of want to play certain moves in a certain order in order to maximize your effectiveness. So that's kind of a closed loop when you've really figured the game out and it becomes more puzzly and not really a game. Lastly, unsatisfying victory conditions. I find beat your own score leaves me wanting more. Now, some players are completely fine with that. They like the whole high score thing and they don't mind trying to beat the last version that they did. It's often praised due to low effort to run the bot, but I prefer something a little more consequential or substantial as far as the win conditions. Another thing to think about is the cognitive load is too great. A lot of games fall into this. I've listed Madara. The thing about Madara is that it's got 4 different roles that need to be played regardless of the number of players you actually have at the table. So if you're playing 4 people at a table, everybody takes 1 role. If you've got 2 people at the table, then you're each going to share 2. But in solo, you have to play all 4. And so this multi-hand game becomes just a lot of work to do. I think ISS Vanguard has the same issue, where the game is definitely playable solo. It just expands the time because you have one person processing all this information. Also, the solo rules being too fiddly is another thing to watch out for. This happens a lot in games that are trying to reflect human thought and really trying to replicate true decision making under duress. Genotype and Kanban EV both come up as potential examples of this, where it takes a lot of work to kind of plug and chug through what the bot is going to do. And it usually does make pretty good decisions, but the amount of effort to get to that decision sometimes isn't worth the time that you had to put into it. A friend of mine says the juice isn't worth the squeeze. And so when the solo rules are too fiddly, that's one of the issues. One of the last ones I want to talk about is winning a solo game encourages an oddball strategy. I've seen this in Sagrada, and I love Sagrada. It's a great game. But the solo mode that you would play on the table actually incentivizes you to look for certain roll, die rolls. I think it's 5s and 6s. And so as things come up, you recognize, oh, the bot's going to take this because this is the rule set. I need to do this to offset the bot. And now you're not really playing your board. You're trying to sort of play keep away with the bot. One last one to look at is the old version of Terraforming Mars. Now, I know that there's a new automa that has come out for Terraforming Mars. We'll talk about that in a moment. But the way that it came out of the box, where certain core mechanisms were ignored or unused, was super dissatisfying. And I think that's why they came out with the fresh version. So in the original Terraforming Mars, you basically didn't use awards, milestones, rival corporations, and it was hard to kind of get cards into play on those standard projects. You really were better off just using the ones that were listed on the board, throwing an asteroid at the planet, etc., to kind of move that that ranking up and up and up. And the fun was in the cards, and you really were disincentivized to use the cards. Also in Arc Nova, there are the way that game breaks and changes, from phase to phase. The breaks are predetermined in the solo, which is super frustrating because one of the great things about Arc Nova as a multiplayer game is that the rounds don't break at the same time every time you play. But in the solo, it does. So if the core game mechanisms have to be subverted in order to create a solo experience, that is super dissatisfying. So why create a solo mode at all? Here's some of the reasons I use to design a solo mode. One thing, it can increase marketability and accessibility of your own multiplayer design. If I want to sell more games, having a one player option that's good is actually going to increase the amount of sales that I can do. Now, one of the things you'll know is that the solo gaming community is finicky, and they recognize very quickly when a solo mode is sort of slapped on. So really don't just throw one in just to be able to put 1 to 4 on your box. You want to have a good solo mode. It can actually decrease your sales if you have a bad solo mode. You may also want to create your own homemade variant for your own favorite multiplayer game. Now, let's talk about some of the types of solo modes. I have 2 different types that I want to talk about today. One that I call a chaos engine, and another one that is a reactive machine, or just for shorthand, we'll call it a bot. The chaos engine has no structured thought in the opponent. It's really more of an environment that chucks obstacles at your head to increase difficulty. And we're going to go over some examples of what that looks like, but it isn't really thinking. And we're going to put all of that in quotes because obviously paper can't think. But the chaos engine is truly not trying to take anything into account about what's happening in the game. It's literally just randomly throwing challenge or obstacles at you. A reactive machine, though, is a true opponent. It's trying to select options based on the current game state. It is actually trying to suss out a better decision rather than just a random card pull. So let's talk about this, choosing the better solo mode. Which is better? Should I build a chaos engine? Should I build a bot or a reactive machine? Answering this question is how you can get to that. Does the solo mode need to choose its move as a response to the human player's action? If the answer to that is no, then you should use a chaos engine. It's simpler to build. If the answer is yes, then you need a reactive machine. And that's really the only question you've got to answer. Does the solo mode need to choose its move as a response to what the human player does? So let's start looking through some game design examples and see how this might present itself. So here's the structure of a solo game. Basically, you create a stable system with a simple objective. And then what you do is you increase challenge. And there's a few ways that you can do that. First, you can add constraints. And we're going to go over an example of that in just a moment. I can then introduce threats, complications, obstacles that undermine the order of the stable system. And then I can impose limits like time, move constraints, different actions that you can and can't do. And then lastly, the goal of the game ends up being to restore or establish order to that stable system that has been broken by the increase in challenge. So let's look at an example of Free Cell. I think everybody's probably played Free Cell by this point in human history. So let's take a look. What is the stable system with the simple objective that we're trying to do in Free Cell? Free Cell is stack 52 card deck by suit in sequence. It's a very simple thing to do. And if there were no challenges or no constraints involved in that, I could simply lay all the cards out on a table and just start to organize them by suit in sequence. And that wouldn't be much of a game. That's really more of a put away the cards kind of task. So instead, we're going to increase challenge. So the first thing we'll do is add some constraints. That means, let's say, hey, you can only use 4 free cells. So these 4 different cells can hold cards, and that's the only way you can move the cards. Now I can't just put everything out on the table in a particular order. I have to use these 4 free cells. There's a random deal to start. So some cards are going to be covered up, and there's a stable system. I can only touch the card that is exposed, the fully exposed card. The free cells can only hold 1 card. And so now you see that by adding some of these constraints and some of these challenges, I've now created a game system rather than just a task of stack these cards in a particular order. And then now I can play the game and stack those cards in that order. The difficulty, sometimes if you have not enough challenge, you'll have a win rate that's incredibly high. And you can keep track of this as you're building your solo. Play it, see how often you win, and keep track of those statistics. You kind of want a win rate at least at 50%. A lot of folks like to have the ability to get down to more like a third. So I'm going to lose 2 out of 3 games. Those are really tough games. But you don't want to have a game that's so punishing or so unforgiving that you're only winning 5-10% of the games, because people are going to see that as too difficult and really kind of put it away. I like, as you're starting, between 50 and 65% win rate, I think is pretty good. You want it to be challenging so that it is not always an assured thing that you're going to win, but you also don't want to have that you're always going to lose. You want to have that variability of it's kind of a coin flip whether I'm going to win or lose, and I have to make good decisions to do so, and that's where you get that 50 to 65%. Let's take a look at some solo game examples. This is a game called Deep Space D6. I love this game. It doesn't have great replayability. I think you can play it 2 or 3 times and sort of get the loop, but it's a really clean system and I like the way it works. The objective here is to survive all threats and defeat the big boss. So the stable system is there's a shipboard that has shields, hull, and different crew abilities, and it's really dice management. You're going to roll dice, and then you're going to place those dice on the board in different places. The randomness of the crew activation, which parts of the ship you get to use, is based on the rolling of the dice. So that already increases challenge by creating the fact that you have to roll. The rolling actually also increases threats on the crew dice. Right here, this little thing that looks like kind of a U, silver U shape, is one of the threat dice. When 3 of those come up, a new threat comes out, and these are the threat cards right here. So you don't have a measured or standardized way that enemies will come out. You can have kind of a flood of enemies through no fault of your own, and you can also kind of keep everything under control. If you're lucky, it'll kind of stay clean. Regular addition of threat cards does happen, so you're not going to be able to sort of get everything into a steady state and then smoothly and comfortably advance. You will always have new threat cards coming in, but when you're rolling those threats on the crew dice, they just come in faster. The threat die activation randomizes which enemies attack each turn. So notice that on these, you've got a 4 and a 5, a 4 and a 6. If I roll a 1 and a 3, and that means that even though I've got all these enemies out here, none of them actually triggers, and so I don't take any damage. However, if I roll a 4, I'm going to take hits from both of these, the assault cruiser and the raiders. So there is a little bit of challenge there as well. Now, restoring order means that I take my crew dice, I place them to mitigate or eliminate the threat cards, and kind of keep my ship intact until I reach the end of the threat deck. The system is making its decisions, and we'll loosely put that in quotes, by just doing a random card draw or random die rolls. It's not thinking. And so when we look at what kind of engine this is a chaos engine. Because all it needs to do, it doesn't care what the human does. It just needs to randomly assign threat cards that come out of a deck. When you roll the threat dice and it turns up a certain way, you'll pull another card, but it's not actually keeping track of what you are doing. It's just throwing things at your head throughout the game. So that is a chaos engine. Another game that I really like is called Honorim. I actually have never played this game on a table. I have the app for this game and I love it. I've probably played, I'm not joking, at least 1,300 games of this, and I really like it. The objective is to unlock 8 doors, and there's 4 green, 4 tan, 4 blue, and 4 red. So the stable system, there's a set collection of colored symbol cards, and then it increases the challenge by placing constraints on the card placement. I am placing cards down in order, but I can't put matching icons next to each other. So you see here that I've got a sun, a moon, a key. I can't put 2 moons next to each other is how it works. I can't put 2 suns next to each other. Choosing how to clear shadow cards on the deck, and that's these right here, these little shadow cards. I can either discard a key, I can pull cards from the deck. There's a bunch of ways that works. And we actually can take a look here at this. This is the app, and this is me playing the app. And so I put out a sun, and here comes a shadow card, and so now I can burn a key, or I can throw away my entire hand to take care of that shadow card. Out comes this, and I can actually use the key to unlock that door, and now I've got one of the 8 doors that I need done. It's a very clean game, and once I've got a set of 3, like I do here, sun, key, sun, that gives me the unlock here. Here comes another shadow card. Now I have to throw away my whole hand in order to deal with that. And there they go. As you can see, there's a finite number of cards. And so there is a possibility that you'll run out of cards before you're able to unlock all 8 doors. The constant deck reshuffling after the short-term goal is achieved means that I can't predict what's coming out. I have to kind of keep track of the number of cards, how many green, how many red, etc. have already come out, and so it can be challenging to keep track of that in real time. But the goal here is to restore order, and you minimize the negative impact of the shadow cards. You use the keys to draw the top 5 cards, discard one, and reorder the last 4, so I can kind of set myself up for a big play. And I can open doors with sets or with keys. The system is making its decision by a randomized card order, and that card order is changing frequently. As you saw, this deck shuffled 3 or 4 times just in the little bit that I was talking. And so when we think about what kind of opponent that is, it's absolutely a chaos engine, because there is no real discussion about what the player is doing. It's simply when X occurs, shuffle deck, and that's all it is. So chaos engines are easier to build, and I think they are good. I mean, they are really good. Everybody's played Pandemic, right? Pandemic is a really clean chaos engine. Randomized conflict to scale difficulty is good, and the environment is often the antagonist. So I think that's really important to understand, is that you're kind of playing against the game system itself. And the game system isn't paying attention to what you're doing or trying to subvert what you're doing. It's just sort of throwing more things at you to make it harder. Deck mining and deck as a clock are common constraints. That's often used in Pandemic, where you've got a number of city cards and you're going to pull 2 every time a player makes moves. And so there's a finite number of moves in the game. Late game difficulty, throwing more obstacles at a player, is very common. As the epidemics continue to hit in Pandemic, you pull more and more cards each time that happens. So it sort of escalates the amount of danger as the game moves forward. And the decision quality from the Chaos Engine never improves, because it's really not making decisions. All it does is throw more stuff at your head. And this applies to both one-player games and also co-op games, because as we know, Pandemic is a 1 to 4 player game. Base Pandemic expansions take that to even higher player counts, but essentially the game loop can be played solo. So let's take a look at it. The objective here is to cure all diseases, right? So this is a co-op example. It's a stable system. You take 4 actions and then you draw 2 cards. And so you're really just trying to contain the illness on the board in time to cure all 4 of the diseases. The increased challenge is by the regular spread of disease each turn, and so that escalates as the game progresses. The more epidemics that occur, the faster the diseases will spread. Outbreaks accelerate that spread of disease, and then, of course, the deck construction guarantees that epidemics are going to spread the disease, because the way you create that base deck evenly distributes the epidemics, and so you're likely to have more and more outbreaks as you go into the game. You also have 4 separate diseases to cure, and you need 5 matching cards for each, except for one of the rolls that allows you to do it with 4. There's actually a couple of rolls that let you break that kind of core loop, but for most of the rolls, you need 5 cards to cure a disease. And then the constraints on how characters can share cards. Sometimes they have to be in the same physical space. They have to both go to a certain city before they can actually share that card. And so that creates a lot of complexity around, where am I going to move in order to do what action in order to maintain some stability in the game state. You restore order by removing disease cubes and by curing disease. And how does the system make its decisions? Random card draws. That's it. I mean, there's not even dice. You just have cards. So what kind of opponent is this? It is absolutely a chaos engine. It's just throwing things at your head. Now notice, I'm not saying this in a disparaging way at all. Chaos engines are super fun. I love Pandemic, but it doesn't require knowledge about what your intent is as a player in order for it to provide you with sufficient challenge. It's not really playing against you. It's just sort of presenting more obstacles that you need to manage. Another good example for co-op is this War of Mine. Again, very similar approach here. You just need to survive until there's a ceasefire. And this is a pretty brutal game when you get right down to it. You take daytime actions, you'll eat and drink. Your characters will scavenge at nighttime to try to give themselves a little more advantage for the next day, and then they will sleep. And then the challenge is actually increased by the fact that when you do scavenge, any noise that you make, and there's rules for noise, attracts a risk of attack. And so you really do put yourself in trouble if you do too much of that. So it's kind of a pressure luck. Also, you have chapter objectives that add side quests, and the fail conditions are absolutely brutal. And so sometimes you'll sort of take that and be able to predict what's going to happen. Most of the time, you're really desperate to try to satisfy those chapter objectives so you don't have to take this huge fail condition. Tougher cards are added to the Residence and the Night Raid decks in the later chapters. So you kind of start off slow and easy just to get your feet under you, and then it really starts to kind of crush you in the second chapter. And so that is pre-planned. So it doesn't require you to do anything as a player. It just happens. Also, easy or helpful cards are often single use. So you might find things that are very valuable. You might find things that are easy to accomplish, but they are few and far between. Later chapter cards are a lot tougher, especially when you get into the crime wave, and that just kind of shows the desperation of the population that you are living within. And so to restore order, you have to try to mitigate those risks at the daytime. Every day, you're trying to kind of keep your wounds and your illness and your fatigue and your misery up within kind of a good level. The character states fluctuate based on what actually happens. And so it's really important to manage those, or else you could trigger a lose condition for the whole game. And the system makes its decisions by die rolls. There are 2 different dice that you're going to roll, and also random card draws. And so as we have seen, that is very much a chaos engine. It isn't taking into account what you're doing. It's just providing more challenge through kind of a if-then set of rules. So, okay, we've seen a lot of chaos engines. Well, when should I build a reactive machine? When the chaos undermines the user experience is really when I say you got to have a reactive machine. And that means that the bot needs specific information from my turn to make its choice. That's why I call it a reactive machine, because it needs to know what I did in order to react to it, not just to process a dumb rule set, a not smart rule set that just if then, but it needs to know like a bot in chess, right? If you're going to create a chess bot, that bot needs to know exactly what the game state, the board state looks like before it can make a decision. You can't have a chaos engine running your chessboard. When random results are unrealistic or implausible, especially, I think a good indication would be chess. If you had a chaos engine running a chessboard and it moved a pawn 5 spaces, diagonally, and took moves that were not appropriate, not within the rule set. Also, random results where clearly a good move would be this, but the bot, not knowing anything, moved something that exposed it to error. And so you want to definitely have a reactive machine to avoid making bad decisions based on that game state. And that game state is the board layout, what resources are available. When the game state really matters and it will drive decision making, that's when you need a reactive machine. And lastly, when my move's intent as the human, the intent of my move would trigger a reaction from another human player. This is really good if you're trying to fake out a human. You want the bot to also be able to be faked out, or to kind of sniff out when it's trying to be faked out and maybe, zhuzh in another direction. Here is a really good example of when this works. So this is the Automa for Terraforming Mars. I haven't had a chance to play it, but I've read about it. And so this is the standalone product that actually, augments or enhances Terraforming Mars and really sidesteps all of those problems I was talking about before. It provides a new solo experience when playing Terraforming Mars. Instead of racing against the clock, the Automa lets you compete against corporations run by algorithms and special cards. It makes it possible for you to add any expansions to create the challenge you're looking for. That is exactly what that game needed in order to make it feel like I'm playing against another person, not just a game system that's trying to get me to a high score. So let's talk about designing your own artificial intelligence. Again, we're talking about on paper. While we do have access to Claude and ChatGPT and all these wonderful tools, we are limiting our discussion here to paper. So when you're designing a chaos engine, it's usually not necessary, to sort of create a whole new engine. It's kind of baked into the game. You identify threats that destabilize the system, randomize how those threats get deployed, whether it's new rules or decks or charts or dice or whatever. Then you'll scale those threats to increase the frequency or power of those randomized threats being deployed. So you want them to kind of start slow in the early game, pile on in the late game, and then you want to constrain player actions, resources, or time. And if you do a combination of all of that and you get it just right, then you're going to be in great shape. That's a chaos engine. So let's really talk about a reactive machine. So when I started trying to build one of these and really take into account how is a piece of paper going to make a good decision, basically, I started by listing all of the relative data points that would inform an opponent's decision. What does a person who's playing this game need to care about in order to make an effective decision? And I make a big old list of that, and usually it's a very long list. Then I would identify major changes to the game state. What can a human's decision do to change the game state? Those are some of the things that the bot needs to be able to keep track of. And this is where a reactive machine that is designed to model human thought can blow up and get way out of control. So it's okay in this early stage to start off thinking about everything, but we are going to try to narrow that down as we go to get something that's easy to play. Third is define plausible outputs. What does a good move look like is really what we're going for. So that first step, what's all the things that the machine needs to be aware of? 2, what are the changes to the game state that might trigger it to make a decision? And then 3, what does a good decision look like? And then 4, assess and exclude unnecessary data. And that's where we as designers go through and say, okay, here are the 25 things that might actually influence a person's decision, but these 7 are the most important. And the rest of them, while nice to have, we can set those aside. The bot doesn't need to know this level, this granularity. And then 5, we need to program those strategies into the tool. So basically, we're leaning out bad choices so that those aren't even possible for the machine to make. If the machine only has good options to select, then whatever option it selects is going to be a good option. And so that's what this process does, is really identify how do we remove bad choices from the view of the reactive machine. And coding the tool needs to make sure that the output can't be predictable to the user. So however I put that on paper, that piece of paper needs to not give away the game and showcase what that bot is likely to do. And that's why I call it encode the tool. So let's look at an example of that with respect to Breakaway Football. If you haven't seen Breakaway Football, there's tons of videos out on the Breakaway, on the Uplink Underground YouTube channel. There's tons, and there at this stage, I think there's at least 80 videos that go over how this game is played. But essentially, it's an American football game where you're the head coach calling all the offensive and defensive plays. Yardage is expressed in 5-yard chunks, so you actually move the little ball marker between the white lines. And so essentially, plays are single-digit values. Here we see a run value of 3. If that goes up against a run defense of 1, 3 minus 1 is 2, and you would move 2 lines. That's a 10-yard gain. It's much more intricate than that, but basically that's what happens. And so what we're looking for is, how does the decision-making happen? I am very proud to say that Breakaway Football has been awarded the Stomp of Approval in 2024 by the Solosaurus podcast. And that was a tremendous honor for us, and I will talk about that anytime I get a chance. But it definitely identified how the bot that you're playing against feels like you're playing against a real person. And that was absolutely by design. So this is how some of our teams operate. This is the Blacksmiths. They're based on the 1978 Pittsburgh Steelers. We try to have helmets that are inspired by particular teams. And of course, the mechanisms that are in play for those teams help the play experience feel like you're coaching that particular team from history. This is the Horsemen, which is the Dallas Cowboys from the same year, 1978. And so I took these two because they actually played against each other in the Super Bowl. And so the way that the game works is you would actually have the player puts down their call first. So the offense places their play first on the board. And then the defense will consider what that offensive formation is. So that's a piece of imperfect information that's being given to the defense. That formation suggests run or pass or suggests play strength, and then they will place their defense on the board afterwards to combat whatever that is. And then both of those are flipped over and resolved. In the blacksmiths only have two formations, so they're close as their run heavy and balance as their pro set, while the defensive formations for the horsemen, they actually have three. They have a run heavy, a balanced, and a pass heavy. So knowing this is important, because if they come out with one look, it may actually trigger the defense to call a different type of defense. So this was our version 1. So now that you kind of know how it works, our version 1 was a simple random card draw off of the offense's deck. And this is kind of how it worked. The bot on offense would draw a card. It would actually burn the top card, and then it would draw the second card. This was to prevent the human from knowing what formation was coming up, but it still didn't quite help the bot make a good decision, because if you had a third and super duper long and it came out with some short pass or a small run, that wouldn't make a lot of sense. And so instead, the version 2, which was released in April of 2020, does a much, much better job, and this is the one that was award-winning, of identifying the game state. So remember, in a reactive machine, it needs to know what the game state is in order to make a good decision. Well, here it knows on first down and first, second, third, or fourth, and the distance, which is expressed in the number of lines it takes to get to a milestone, which is the next first down or the end zone. So if I know that I'm in a first and long situation where I have 5 or more lines to travel before I reach a milestone, that this is what it's going to call. It's going to go 50-50 close versus pro set. But when it has a very long way to go, third or fourth down, and 5 or more to go, it is only going to call pro set because that has better passing. The same is true down here on first and 1 or 2. It's going to lean heavily on its close formation because that is a run heavy formation. And very infrequently it will call pro set, which still has good run in it, but has also some passing. Here we can identify which of these charts we're going to roll on based on the game state itself, which we've expressed as down plus distance. So here, first and 5, let's say for fun, this is a first and 5. We can get the formation here, but we need to know what its attitude is. What is it going to try to accomplish? And in a very simple way, this can be seen as conservative, balanced, and aggressive, but not every team holds to that. Sometimes they'll lean on certain types of plays in the different color groupings. And so here what we see is first and 5, 1 plus 5 is 6. 6 is green 18. So I'm going to roll here to get the formation, but then I'm going to roll again here to get a coded play type. So let's say that they roll and we see the game state is a 6, which means it's green 18. And then they roll on the green 18. And then they'll flip over to the back of the card and find the answer. And so the way this works is, let's say that I roll a 2, which is gold dragon. And let's say up here I rolled close. So if I had rolled a 2 and a 2, that would be close gold dragon. Over here, close gold dragon is a power run of 3. If I had rolled that same die and it came up a 4 and a 1, the 4 is pro set, the 1 is jet razor. So pro set jet razor is a finesse run of 4. So we have available to us a range of plays that make sense based on different down and distance scenarios and different formations. So the first thing that you do here is you choose the formation, which is right here. Let's say it's first and 3, and then they go ahead and roll, and they are now getting a 5 result. So that is a first and 3. We roll a 5. We see that they come out in pro set. And then it's first and 4 lines to go right here. We see that 1 plus 4 is 5. That means we're rolling on red 98. So we have pro set, red 98. We go ahead and roll, and we get Mike Dragon. And so here we have pro set Mike Dragon, and that is a special run of 3. Now, to put this together required a good bit of planning as far as what goes where, but functionally it's a very simple approach. The player is only rolling a 6-sided die twice, once to get the formation, once to get the play call, and the play calls are all appropriate to the down and distance situations. Moving now to defense, the AI on defense, the version 1, which is currently discontinued, was just a straight a set of die rolls. It actually had modifiers here for how many dice you would roll. And so depending on the formation that came out, you would either roll 1, 2, or 3 dice. And then some situations here would actually have you add or subtract a die. You'd simply roll on the chart and it would tell you what defense. This was okay because at least it was smarter than a random card pull, but it's still, the variable die pool was kind of tough to manage, especially considering that the offense used dice in a different way. So instead, we wanted to kind of sidestep these problems. You know, the difference from the offense increased that cognitive load. I have to realize that I have one set of rules for offense, but then I have to do something completely different to get a defensive call, and that was just dissatisfying. Die pool clusters made the play calls kind of samey in different parts of the chart. When you're rolling 1 die, you can get a die roll from 1 to 6. And so it invalidated everything else, which is fine. We would kind of load up things that were good for run heavy in the first 6. And then when you'd roll 2 dice, you have a 2 through 12, but you're still kind of clustering, 5, 6, 7, 8. And then when you roll 3 dice, now you've got 3 to 18, but really you're kind of clustering around 8, 9, 10, 11. So, this area here in the middle tended to be overused relative to other parts of the chart. Instead, now we have the version 2 of the defense, and I'm not going to kind of step through this. There's actually a video that goes over how to use this, but essentially it's the exact same process where you roll 1 die for the opponent formation and then 1 die for the play call. And it's a very simple approach that matches what the offense does. The features and successes of a reactive machine: first, you can embed a strategy. So in those different pieces of paper and how they are used are definite strategies. If we've got, in a football context, a short yardage situation, some teams might want to do a lot of power running or inside running in those. Other teams might actually want to do more short passing or play action passing to subvert those expectations. Those strategies are embedded inside of the tool without being obvious. You can encode the action by using those, smoke joker or jet razor kind of nonsense words that match what quarterbacks actually say in professional football when they're at the line and trying to change plays at the line. It gives it that sort of verisimilitude, but it also hides the actual play call. And so encoding those actions helps to suspend disbelief and also helps me not have to try to guess what the tool is doing. I can just really focus on my own strategy. It does improve choice too, because it limits or excludes situationally bad choices for the bot. So you don't have to worry about it making a dumb decision, play over play. It does simplify the decisions too, because all I have to do is roll a 6-sided die twice. I can get to the actual play call without really having to think too much about it. So I get to focus on my own strategy. And the steps should be included on the UI instructions, right? So the user interface should prompt the user how to use the tool in order to get to the right answer. The defensive one that I showed you has the instructions on how to use it. The offensive one doesn't. And I think if we went back in time, back to 2020, I would include more detail about here's how you use the tool. Once you do it once or twice, it becomes very internalized. It's a really easy thing to process, but it is better if you have the steps actually on the paper. And so that's the recap. We explored what worked about solo modes and what you need to watch out for. We talked about Chaos Engine versus Reactive Machine. I offered some guidance on how you can create your own paper-based solo mode, and we talked about how Breakaway Football's AI grew from something that was only okay to something that was award-winning. If you do have any questions that you'd like to pose to us, feel free to reach out to us at Uplink Underground Games at Cox.net. We're more than happy to include you in the conversation, clarify anything that you might find needs clarifying here. And thank you for watching. This has been a lot of fun.